Hello students, how are you all? So we are going to start the next lecture of chapter motion, measurement and distances. So we have already completed 2 lectures. So this is the third lecture of motion, measurement and distances. Okay. So without wasting any time, let's start with the topic. And as you all know, my name is Aditya Jain. Okay. Yeah. So we'll start. Yeah. So we'll start with the third part of the chapter, motion, measurement and distances. Okay, let's begin. So today we are going to cover 2 topics basically in this lecture, which is of measurement of distance and speed. The second one is the concept of average speed. Okay, so in the previous lecture, we have already discussed about motion of several types of motion which are happening around us. So that part we have discussed. We have basically covered rectilinear motion, circular motion, yeah, rotational motion, vibratory motion. These types of motion we have already covered in the previous topic. Okay, so in this topic we are going to study about measurement of distance and speed, and then end our discussion on the topic of average speed. Okay, so let's start with the topic. So first, measurement of distance. Okay, first measurement of distance. So basically distance is what we have already seen. Distance is the total path length traveled. Total path length traveled by any object. Okay, total path length traveled by any object or any body, that is known as distance. Okay, so in distance, what we are concerned with, we are concerned with basically path length. If I tell you, we are basically concerned with this length. That basically you have to measure length to calculate the distance traveled by any body or the quantity distance you have to measure in this. Okay, so what are the things or what are the devices for we can use for measurement? Because in the previous case, or if I talk about earlier times, what we use some footsteps to calculate the distance. Like this, I am traveling like this on a length of a floor, and I'm just matching my floors or footstep on the floor and counting the number of footsteps completed to cover a certain distance. Suppose I'm talking about a cricket pitch. In our childhood days, we used to measure the length of the pitch by the footsteps. We are going from A to B. Suppose this is A, this is B. So you are traveling from A to B by calculating the number of foots required. So whatever the number of foots required is given as the distance as 22 footsteps. Suppose 22 footsteps or 23 footsteps. So that is the unit we use in earlier times. Other unit we can use is of hand span. Let's suppose for measuring the length of this span. For measuring the length of this span, what can I do? I can measure this as a length of hand span like this. So I'll say the length or distance of this span is of 1 hand span. Okay. The other thing or the third unit which we use is the arm length. Arm length means the length of my arm. Arm length means the length of my arm. But yeah, the difficulty in these measurements, which we name as footstep, hand span, and arm length, is that these are different for individual human beings, if I say. Because a person can have a longer arm length, yes, by birth, because these are by birth. A person can have a long footstep, a person can have a short footstep. So it depends on individual to individual. So they can't be a standard unit of distance. It depends upon individual. Suppose the footstep for an individual is of length 15 centimeter, and for other one it is 10 centimeter. So you can't get a standard value. It depends upon individual. Okay, but yeah, for local purposes or in the previous times we use this measurement of length. Okay, so now the modern or the more accurate measurement of length is instruments are these which are shown on the right side. So first is this one which is known as ruler or any standard scale. Okay, this gives you the value basically. This gives you the exact value of length because it is a standardized measurement. It is a standardized measurement which is universally accepted. So suppose this is a centimeter scale. So these are the markings shown as 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. So from this you can easily get the length of any object accurately. Now talking about this second thing is the tape, measuring tape. This is again a standard device to measure the length in which you stretch the tape outside and measure the length, whichever length you are able to measure, or whichever you are interested to measure basically. Okay. The third is this, which is known as screw gauge. This instrument is known as screw gauge. This works like that. It has a structure like this. It has a structure like this. This is a screw. So whatever objects you are interested to calculate distance of, or basically it is calculated for measuring thicknesses. So you put that object between this gap. You put that object between that gap and try to tight it. Try to make it tight by moving the screw. This is the screw. There is a setup like this. You move like this and the screw tightens. So tight it until the object gets tightened between the screw and this part. So now from this you will be, there is a scale here. There is a scale in this part, circular part. From that you will be able to get the thickness or length of that object, whichever you are interested in. Okay. Now the last one is the vernier caliper. Vernier caliper. This is again a length measuring device. As you can see, there is a gap like this. So whatever object you are interested, just place it here between these two arrows. Yeah, just tight it and measure the readings from here. This is the scale. So this is the reading scale used in vernier caliper. So from this you can be able to measure distances up to millimeters accurately. Not up to centimeters, but up to millimeter. And you know that 1 centimeter equals to 10 millimeter. We have already seen it. And 1 meter equals to 100 centimeter. And 1 kilometer equals to 1000 meters. That we have already seen in the previous lecture, that conversion of units. And what about SI unit of distance? So SI unit of distance is the meter, which is shown by small m. This is the SI unit, and this is the interconversion between the units we have already seen. So I think the measurement of length is clear. So how to measure the length with different apparatus. The apparatus or the method on the left are inaccurate because they depend upon individual to individual, footstep, handspan and arm length. But these one on the right, like ruler, measuring tape, screw gauge, vernier caliper, these are the more accurate instrument for measuring the distance. So I hope this is clear how to measure distance by different instruments. Okay. So we'll move forward to the topic speed. Now what is speed? Now we are concerned with measurement of speed, that how to measure the speed now. So basically just get the feel of speed, that what is speed in day-to-day life. If you can see or the image on the left, what is this showing? This is a speedometer of a car named as Aston Martin. I hope everyone of you heard about Aston Martin. Yeah, this is a very famous car company, luxurious car company. So Aston Martin, this is a speedometer. What do we say this as? Speedometer. So speedometer is showing some readings on a circular scales. These readings are nothing but the speed. So speed is a physical quantity which shows the rate of change of distance of any object. Yeah. So speed is any physical quantity which shows the rate of change of distance of an object. So what do you mean by rate? Rate means change with respect to time. Rate means change with respect to time. So for any quantity, if you measure the change of that quantity with respect to time, then that is known as rate of that quantity. So we are concerned with rate of change of distance, which is known as speed. Okay. So this is the speedometer which is showing speed, and the image on the right. What is this setup called as? You have seen that setup in the Olympics. Yeah. Where there is some race, 100-meter race, 200-meter race. So what do referee do? A person at the starting point just moves the piston, pulls the piston, and the gun goes on. So this is the symbol, or this is the signal of race starting. So as soon as this person is sitting at the finishing point. This is at the starting point. So whenever or as soon as this person at the finishing point hears the sound of gun firing, he immediately starts the stopwatch. Okay. And at the end of the race, what he does, when the athlete crosses the finishing line, he just presses the stopwatch to measure the time interval. So what he's doing, he's measuring the time interval. He's measuring the time interval. So from the stopwatch, you will get the time interval, and you will know the distance much before the race. Yeah. because you know how much distance of race is going on. So you know distance, you know time. So you will be able to calculate speed from that. Yeah, you will be able to calculate speed from that. Before going into that concept, just imagine or just be aware that there are two types of speed. If I say one is simple speed and another one is known as average speed. So there are two terms basically, speed and average speed. We have to basically bifurcate between average speed and speed. So whatever this speedometer is giving is known as speed. Okay. And whatever this setup on the right side is giving is known as average speed. So we'll look into detail that what is speed and what is average speed. Okay. So I hope it is clear that speed is the rate of change of distance, and it is basically of two types. It can be speed, it can be average speed. Yeah. Let's see what is speed. Let's see what is average speed now. Okay. So now see this diagram on the left. What is being here? A car is traveling. You can see a violet color car which is traveling. So there is a scale attached to the road and which is calculating the distance is miles. Okay. So if you carefully see, there is a timer going on at the top, which is showing that how much time the car is taking to travel this much distance. So suppose the car started journey from 0 and traveled up to 5 miles because the distance is in miles. So the distance the car has traveled is 5 miles. So what is the time taken by the car for this distance to travel? It is written here. It is 0.2 hours. So time is 0.2 hours. So this is the case that the total distance is given and total time taken is given. Now what is the speed? Speed is rate of change of distance, which means speed is equals to distance traveled divided by time taken. Okay, distance traveled by time taken. So if I see in this situation, what is the distance traveled? It is 5 miles. What is the time taken? 0.2 hours. So this will give you 25 miles per hour. Yes or no? When you solve this 5 by 0.2, it will give you 25 miles per hour. So what it is showing that this car is traveling 25 miles in a single hour. This car is traveling 25 miles in a single hour. But yeah, if you can think of the practical situation, car has just started from the initial point. So we can't say this car has started from 25 miles per hour because it has started from zero speed. Then the speed will increase gradually. So this speed is known as average speed basically, because during the entire journey of the car from 0 to 5 miles, its speed can't be constant because there's some traffic on the road at which the car suddenly brakes or speed slows up. There should be some portion during the journey where the car was speeding up. Yeah, so that depends upon the journey. But yeah, for the entire journey, what you are calculating is if I correct this formula, what you are calculating exactly is total distance travel divided by total time taken. So this quantity, total distance traveled by total time taken, is known as average speed. This is known as average speed, which is for the entire journey. Okay. So average speed does not mean the speed is constant at every part of the journey. Yeah, it means you are concerned with the total distance and total time. Speed can be different at different points of time, but for the entire journey, you are describing this quantity, which is average speed. Getting my point? So now the image on the left of this, which is the speedometer, shows some speed at particular instant of time. Suppose I am traveling and during my journey, the speedometer shows different readings at different interval of time. Yes or no? Every seconds the measurement changes. So what it measures? It measures speed. So this speed is also known as instantaneous speed. Instantaneous speed. Instantaneous means at an instant. So suppose you are concerned with calculating the speed at any particular point of time. Suppose at 2 seconds. So whatever speed the body has at 2 seconds only, not before that, not after that, exactly at 2 seconds. So this velocity or speed is known as instantaneous speed. So instantaneous speed is the speed at any particular point of time, and average speed is the speed during the entire journey, which is calculated by total distance traveled by total time taken. So the difference is clear. Instantaneous speed is measured at a particular interval of time, not before that, not after that, exactly at that time. But average speed is defined for the entire journey. Okay, the thing is clear. Now we're talking about SI unit. Obviously, speed and average speed both are having same formula, distance by time. So what is the SI unit of distance? It is meter. What is SI unit of time? Seconds. So the SI unit of speed or average speed is meter per second. Although it can be measured in kilometer per hour also. Yeah. So if you see the image on the right, what is written here? The average speed of a skydiver is 200 kilometer per hour. What is written? The average speed of a skydiver is 200 kilometer per hour, or it can be said as 124 meter per hour. So it doesn't mean that the skydiver has suddenly started traveling from 200 kilometer per hour during its entire journey. Because as soon as he falls off or he jumps off of the plane during skydiving, its speed gradually starts increasing. It doesn't like that as soon as he jump off, the speed is 200 kilometer per hour. So what is this 200 kilometer per hour showing? It is showing the average speed of the skydiver. It is showing the average speed of the skydiver, that whatever the total distance he has traveled from the jump off point to the ground, divided by the total time taken during that entire journey. That is giving you a speed which is known as average speed. That's why the word is written also here. The average speed of a skydiver. Okay. So whatever speed the speedometer in a car gives or any automobile gives is the instantaneous speed. Average speed is the total distance during the entire journey. Total distance taken, total distance traveled divided by total time taken. Both of them will have a SI unit meter per seconds. It can be measured in meter per hour. It can be measured in kilometer per hour, but the SI unit is meter per second. So I hope this is clear what is speed and what is average speed. Okay. So now we'll see the more depth concept of average speed with the help of a video. Okay. We'll start the video.
Video what average speed of an object in motion is. Let's understand it.
So she is basically defining the concept of average speed of an object in motion that we have already seen. Let's move on.
More time, as this is an important concept. First of all, how will you define the speed of an object moving along some path? The speed of an object is the distance traveled by an object over the time it.
So we have already defined that speed is defined as distance traveled divided by time taken, or distance traveled over time taken, or you can also say rate of distance traveled. Yeah.
To complete that distance. Say the distance d is 20 kilometers and the time it takes to cover this distance is 4 hours.
Now what is being given? That the car is traveling 20 kilometers and it is taking a time of 4 hours to complete this journey. So from there we can find a quantity. Let's see.
What will be the speed of the car then?
Yeah. So what will be the speed then? You will know distance traveled by time taken. So distance traveled is 20 kilometers and time taken is 4 hours. So you will divide 20 divided by 4, which will give you 5 kilometers per hour.
The speed will be 20 over 4. That's 5 kilometers per hour. Look at the value carefully. What does it tell us?
So what does this value telling you? Should it telling you that this value is a constant quantity, because 5 kilometers per hour is a constant value. So what is the basic inference of that? Let's see.
Does it mean that our object traveled 5 kilometers in every hour?
Yeah, yes or no? 5 kilometers per hour means that our object or the car moves 5 kilometers in every 1 hour. So the total distance is 20 kilometers in 4 hours.
Or in other words, does the value of speed say that the object traveled at a constant speed? Well, we know for a fact that the car does not magically start directly at.
So we already know that the car does not magically start at 5 kilometers per hour. We start from rest, or also if it is traveling during a journey, or this part of the path of the car is taken from a journey, mid part of the journey. So that doesn't mean that the car is always traveling with 5 kilometers per hour, because there can be a traffic area also. There can be urban area, rural area during the journey at which the car speed up or the car will slow down. Yeah.
The speed of 5 kilometers per hour. Its speed gradually increases. So if the car was starting from this point, then its speed cannot be constant. What if this was not the starting point of the car? Well, we still cannot say whether the speed was constant or not, because maybe the car was slow in the first half of the journey and then sped up in the second half.
Get the point? It can be a point that this is a part of a journey in which the car is not still traveling with the constant speed. It was first traveling with a slower speed during the first half of the journey, and then it speed up during the last half of the journey, or the second part of the journey.
The given data does not imply in any way that the car will cover 5 kilometers in every hour.
So this data is not confirming that the car is traveling 5 kilometers in every hour. This is basically some other quantity, not speed exactly.
So if this is not a constant speed, then what is the speed called? This speed is called average speed.
This was the average speed I was telling about, the total distance traveled divided by total time taken. That is average speed, not speed, because at any instant of time, speed is different.
Average speed is defined as the total distance covered by an object over the total time taken. So in our example, we're given a total distance that the car travels and the total time taken by it to cover that distance. And hence we calculated the average speed of the car for the entire journey.
So now got the point that average speed is the total distance traveled, total time taken. So basically we are given total distance traveled, that is 20 kilometer, and total time taken, that was given as 4 hours. So whatever we have calculated as 5 kilometer per hour is the average speed, not the speed, because it is not every time 5 kilometer per hour during the entire journey.
I'm sure that you're clear with the idea of average speed now. So what's next? Look at the unit of speed used in the example. The unit of speed in this example is kilometers per hour, or kmph, and it's one of the most common units of speed.
Now we have seen the SI unit of speed was meter per second, okay? But the most common units of speed is kilometer per hour. Although the SI unit is meter per second, but the most common unit of speed which is used is kilometer per hour.
Yes, this unit is also used in speedometers. Suppose a car is traveling.
Again, see this unit which we have seen in the case of Aston Martin speedometer, that was also shown in the unit of kilometer per hour. Okay.
From point A to point B, and the speedometer shows these values at these 3 instants. Nope.
So suppose what is happening, a car is traveling from A to B, and at any instant of time, suppose at T1 time, at T2 time, and T3 time, the speedometer of the car has a reading which is given as 20 km per hour, 30 km per hour, and 50 km per hour respectively.
At time T2, the speedometer reads 30 kilometers per hour. What does that mean?
Now what does that mean? This speedometer is giving you speed at any particular point of time. Suppose at T2 time it is giving you 30 km per hour. So this speed which is given at a particular instant T2 is now known as speed, or you can say instantaneous speed, because this is not the speed of the entire journey, it is the speed at a particular time interval T2, which is known as instantaneous speed. So I think the difference is clear. What is average speed and what is instantaneous speed? If I basically define or bifurcate that, for average speed you require some time interval, that from T1 time to T2 time, what is the total distance traveled. In that case, whatever you are calculating is the average speed. But if it is given a particular time, suppose at time T2, there is no interval of time involved, then at that point of time, what you are calculating is the instantaneous speed at that particular point of time. The point is clear? Okay.
Is this an average speed? No, it's not an average speed. The speedometer shows us the instantaneous speed. It is the speed at that instant of time.
That's what I was telling. It is the instantaneous speed. That is the speed at that instant of time.
Here, the speedometer reads 30 kilometers per hour. It means at that moment of time, the car is traveling at this speed. It does not say that the car has been traveling at this speed or will travel at this speed. The value is only at that instant.
So that I already told you that this instantaneous speed at that point of time only T2. Not before that, and also not after that, exactly at T2. That's why it is known as instantaneous at a particular instant of time.
And that is why we see that the pointer is never really constant in the speedometer. It keeps fluctuating. You are going to learn more about instantaneous.
So this is the thing. That's why during the entire journey, speedometer always changes. Yeah, speedometer always changes its values because speed is different as different instant of time. Okay. So now I think you are clear about the difference between instantaneous speed as well as average speed. Okay, I hope this concept is clear. So now let's move on.
Higher grades.
Okay, so if I basically summarize the things, that for time interval, if there is any time interval involved, so for time interval, average speed is defined. Average speed is defined. If you are concerned with any time interval, average speed is defined, and average speed is given by total distance traveled over total time taken. Okay, and the unit is can be meter per second or can be kilometer per hour, kmph, anything. Yeah, but the SI unit is meter per second. And the second thing is known as instantaneous speed. Instantaneous speed. So this speed is defined for particular instant of time. Particular instant of time. Okay, the unit is same again. The unit is same again, meter per second SI unit, or it can be kilometer per hour, which is more common unit in automobiles. Okay, so now I think the basic bifurcation between instantaneous speed and average speed is clear. Okay, now let's see one question. That what must be your car's average speed in order to travel 160 km in 5 hours? So whatever the examiner has directly asked you, that you have to calculate the average speed only. Why? Because there is no particular time interval involved. There is no particular time involved. Actually, there is a total time interval of 5 hours in which car has to travel a distance of 160 km. So what is the average speed now? Average speed will be total distance traveled by car divided by total time taken. Yes or no? Total distance traveled by the car over total time taken. So what is the total distance traveled given to us? It is 160 kilometers. And what is the total time interval? It is of 5 hours. So your answer will be 160 by 5, which will give you 32 kilometer per hour. So that will be the average speed of the car. So I think this is clear how to calculate average speed. Yeah, clear. Now next question. So a cyclist travels 1200 meters in 4 minutes. What is her average speed in meters per second? Okay. So whenever a question in, basically if I talk about the whole physics problems, that whenever problems in physics comes, you have to remember this concept of less. You have to remember this concept of less. Less means L. L means list your data, that whatever data is given to you, and does that data require any change of units? Because ultimately you have to solve the question in SI units. Okay. Now second point is write the equation. LE. Write the equation involved in the question which is required to solve the question. Then solve the equation by putting the values which are given. And now finally give your answer or state your answer in SI units or whichever units the question is asking. So you have to calculate the average speed in meter per second. Meter per second. So basically what is given? Total distance. Total distance is given as 1200 meters and total time taken to cover that distance is given as 4 minutes. So basically the unit of distance is in meter, that's okay, but the unit of time is in minutes. And what we required units in second, meter per second. So first we have to convert, list your data, we are listing the data and converting according to the needs. So I'm converting minutes into seconds. So 1 minute equals to 60 seconds, 1 minute equals to 60 seconds. So 4 minute will be equals to 4 by 60 seconds, which will give you 240 seconds. Yes or no? So now we have got the total time in seconds, total distance in meter. So can't we calculate average speed? Now third step, write the equation, or second step. So equation is average speed equals to total distance travel divided by total time taken. So simply apply this formula. So what is the total distance? 1200 meters. What is the total time? 240. You just need to solve this and you will get your answer in meter per second. So we have used this third step. solve, substitute in the numbers. So we have substitute the numbers. So what we get in the final step, we will state the answer. So what is the answer coming? We will see 24 5 times. Okay, so it will be 5 meters per second. So the answer was asked in meter per second and we have got the answer in meter per second. So our answer is correct, which is meter per second. So the average speed of the cyclist is 5 meters per second. Yeah, remember one thing, that means that doesn't mean this is the constant speed. This is only the average speed. If you are talking about any particular interval of time or particular instant of time, that is known as instantaneous speed. Getting my point? So I think the measurement of length, what we have done, and the measurements of speed, when we have seen what is speed, we have already seen what is average speed, how to basically bifurcate between them. When time interval is involved, you have to calculate average speed. When a particular time is involved, you have to calculate instantaneous speed. Okay. So this is the way to solve the questions. Also, we have already seen the numericals also on this topic. Okay. So I think this step is clear, or this concept is clear. So I hope you like the concept and you have got the basic idea of all the concepts regarding speed, average speed, and measurement of length. So thank you so much. We'll end the session today. Thank you guys.